Perfect. So then let's start with the meeting. So welcome to our Gardener community meeting. So this week we have only one topic. Quickly share my screen. We have only one topic from Ismail, and with that I hand over directly to you, Ismail.
Thank you. Let me share my screen. Okay, can you see it?
Yes.
Okay, so I'm Ismail, and today I would like to talk about Go modules. Basically, the dependency management in Golang was kind of problematic. You have Go paths, you have tools for vendoring, such as dep, and in the end, there was no standard way in the community how to manage the dependencies. So starting with Golang 1.11, the solution was introduced and it was called Go modules. Then the community started adopting Go modules. Already some big projects such as Kubernetes, CRI, or core resignation, they're all opted in Go modules. And so these days we also expect the release of Golang 1.13. And starting with Golang 1.13, the default mode in Golang will be the module mode. So that was some motivation for me to share with you the new way to manage the dependencies, Go modules. So today I would like to make a short intro and to outline some differences between Go paths and Go modules. For this purpose, I'll use the guide of Ligit, one of the main contributors in Kubernetes. Basically, he had a nice separate session for Go modules for CKPI machinery, and he used exactly this guide. I plan to go through it and yeah, to play with Go modules. So feel free to intercept me or to ask questions, and it will be nice if we have discussion. So let's start with the old way Go path. So for the purpose of the tutorial, I'll use two projects. One of them is project A. I'll just clone it to my Go path. So basically, with Go path, you have one source directory, and prior to Go modules, you have to clone and develop your projects inside the Go path. So let me just quickly navigate to it. Go source Ligit. I have to clone the project right here. And let's see what we have inside it. We have a simple main. We require a package B, and we have a subpackage called helpers, which has a function that just prints cake. So we just cloned our project. Note that we have no vendor folder under our project. So if I try to run the change to A, and if is it visible? I forgot to ask.
Yes, it is visible.
Okay, thanks. If I run the main, it will say that it cannot find package B, which is kind of expected, because how the package resolution in Go paths works. First, it tries to find a vendor directory in our package. Currently, we have no vendor directory. Then it finds to resolve relatively the import path relatively to Go path. Basically, it will try in Go path source github.com Ligit, and we have currently we don't have package B installed here, and we don't have it also in Go root. So this is why it fails to resolve the package B. So in this case, we have to go get the package B. And if we check again gopat, when we run go get, it downloaded the dependency in our gopat. So if we try again to run our main, it is executed successfully. So the goto was able to locate package B relatively to the gopat. Okay, so a few things here to note. Basically, what are the benefits that when you have all of your dependency downloaded with gopat, you can develop locally. You don't need network access if you don't need newer dependency, and you have full control over the gopat. Basically, I can go here, edit package B, and continue to develop with it. So what are the problems with gopat? If you note here, we just run go get for package B, but we didn't specify which version of package B. So prior to Go modules, the GoTo was not making difference between versions. So Ligit has a pretty good question here. So what version of package B does package A prefer to use? And the answer from the GoTo is what is a version in gopat. So to handle the version issue, there are tools like dep that will vendor the appropriate version in your vendor and in your package. So this is the first place where the GoTo will check for the import path. The second is the gopat source, and the third is go root. Yeah, basically the major drawback for me of gopat is that you have to structure your directories in the way that gopat requires. You cannot clone your project somewhere else. And yeah, this is already fixed with Go modules. So a few notes about, again, the go get. You specify go get and the import path. This will, prior to Go modules, this will fetch always the master version of your package, and this will also fetch the master version of the dependencies of this package. Yeah, so if we go to Go modules, so let me just remove these two packages from my Go path. I'll go somewhere else outside of gopat, and I'll clone again the project A. Let me just open Visual Codes, change to A. Okay, we have our project clones. If we try to run now the main, it will say that it cannot locate package, the sub package, the helper sub package, and it is not present in gopat. It is not present in go root or in the vendor. So we can now open this package into Go modules using the syntax go mod init and the module path, which is github.com ligit a. Basically, this one here, the module path is kind of the identifier of your module. Yeah, let's run this and let's see that we have a change here. Go mod init created a Go mod file for us, and if we check the content of Go mod, we see two verbs. These are called verbs. We have the first verb module and the module path that we specified. And next we have the Go verb, which specifies the exact portion of Golang. So the interesting that if now we already opted our package A to Go modules. If now we try to run make Go, the Go tool found it detected that we have a dependency. Oops, we have a dependency to package B. It's downloaded it, the appropriate version for us, and then it executed the main. So if we check again the Go file, we see a new verb here, and it is a required verb. It says that for building and running the module, it is package B is required with at least version 1. Yeah, so let's see what we have. Next, we already opted our package A to Go modules. Yeah, so basically let's see whether this package B is located. Let me clear. We still have no vendor directory. We for now have only Go mod and Go sum files created from Go modules. If we check the Go path, we're gonna see that also the package B is not located also in the Go path. So the answer is that modules, there's something called module cache, and it is located under your Go path, LSLA, Go, it should be package mod, and you can see here all of the modules located. So if we try to find our module, it is located right here in the source, and you can note that the module cache is also versions. So this is how the modules can distinguish between different versions of the packages. So there are some utilities with the modules cache. You can basically clean the whole cache with go clean mod cache. It will take a while. Yeah, if we try again to list, it will say that there is no such file directory. The other good thing is that you can explicitly force Go modules to download dependencies to the module cache with Go mod download. No, it is not Go mod download. Yeah, typo. And yeah, if we now check our module cache, we're gonna see that we only have this package. So let me try something. Let's just clean the module cache again. We have nothing in the cache, so let's try to run our main again, but let's pass a variable Go proxy off to our Go tool, which means that we will forbid the Go tool to access the network. So if we try to run this one, it will fail, and it fails with message that the module lookup is disabled. Basically, what happens? We just cleaned the cache. There's nothing in the module cache, and the default behavior of the Go tool is to go to the network and to try to fetch the newest version via the version control systems. So which is kind of problematic, not because when you run Go run or Go build or Go install, you expect basically packages from your vendor to be taken, and you don't expect when you run Go builds that the Go2 requires network connectivity. So basically, this is one of the huge differences. If we want to go without network connectivity, we can vendor our dependencies, which is possible with Go mod vendor command. It will again do module resolution, and we can now see that we have a vendor folder under our package, and the source of package B is located right here. So we have a vendor. Let me try again. Let's just clean the cache, and let's try again to run our main with the vendor folder. And it will again say that the module lookup is disabled. Basically, the default behavior of the Go2 is that it ignores vendor and it tries to reach the network to perform the module resolution. So the fix for that is that they introduce a new parameter which is called -mod, and the value we have to pass is mod vendor. And this will force the Go2 to look up for the import paths in the vendor folder. Yeah, basically, I want to show you also. This is there is an issue in Golang repo. This one with a lot of upvotes to change the default behavior, and when the vendor folder exists, to use mod vendor by default. Yeah, I hope this will be done in 1.14. So do you have any questions? I feel that I go fast through the steps. Or
That's fine.
Okay. So yeah, what are the benefits that we saw now? As you see, we are outside of GoPath, and we can we have means like vendoring. We have also caching for the modules, and yeah, the main advantage is that it allows development outside of GoPath. So let's see how we fetch dependencies with the GoPath mods. We only executed goget legit B, and there was no terms for version. But with Go modules, you can specify exactly what version of your dependency to be fetched for your project. It is basically the syntax is your package or package adds and version. For version, you can specify everything: commit hash or tag or any branch. Yeah, let's continue with the next steps and try to add to see how we add a new dependency to our project. We want to get on GitHub a new module called C, and here we'll specify that we want v1 of C. Okay, if we now check our GoMod file, it is located already here. Now let's just modify our source to use C, and let's add something dummy from C. C. It was cake or yes. Okay, let's vendor C. And if we now check on the vendor, we will have C. And we're gonna check that. We're gonna check the content. It is simply one function that returns cake, please. And we invoked this function here. Okay, if we now run with minus small vendor, we're gonna see that we use the appropriate version of C is fetched, and we can refer it. Okay, that's how you add new dependencies to your project. Okay, so now let's do something. Let's add one more package to our project. It will be D. Well, let's first go get it. Go get D, and we'll get v1 of D. Note that here, when we get C, the version of C was v1. Now, if we check the mod file, the version of C is v1.1. So something happened when we just go get D, and it added a new require statement for D, but it also updated the version for C. So basically, we can check similar behaviors with Gomod's graph. It will show the dependency graph for our requirements. And you're going to see that D requires v1.1 of C, and Gomo just chose v1.1 for the project for package A. So that's kind of problematic also. So it is the behavior, it is not like that, because in that you just specify some overrides to pick up the right version. Also, the same is possible in Golang. If we now just vendor Gomo, let me just clean. If we now vendor the package D, and we run, you'll see that the output of C changed. We didn't change the source, but the output of C, it was like cake please, if you remember. Let me just find it. Yeah, the output of C is here, cake please, the output from v1, and we just updated we added a new dependency, and the output from C changed. So if for some reason we want a concrete version of dependency, or we want to pin a dependency, the way to do that in Go modules is to use the replace verb. So you just specify replace, you put your requirements, and you specify the exact version of it. And in this case, you want v1. Okay, let's do that. And again, go mod vendor. Oops, go mod vendor. And let's run. And here we now expect our output, which is cake please. The replace directive are quite powerful. Basically, you can specify here your forked version of the module. Basically, I can put, if I fork this C, I can put my fork version. Also, I can specify a local version of C, which is quite useful for local development of multiple modules. Basically, if I go and if I git clone C here, and if I go in, let's modify something in C to make a difference. Here we already specified that we require the local version of C. We go to A, and we have to vendor, go mode vendor, and go on mode vendor make cake, and we already use the local version of C. Okay, any questions until now? Do you have some questions? Okay, I'll just revert the C change, and I'll now modify my package to also use package D. And I'll print something from D here. I think the function was oops. Yeah, this is the right function that I want to use from D.
Ismail, can you also show warnings on the command line? I mean, if you make some window updates, so that when some dependencies are updated, that the warnings are shown? Or?
You mean that you're, as far as I know, no, it won't notify you in any way if this is your question, basically.
Because if you use the replace statement, it could be also dangerous. So,
what do you mean? What is the danger with the replace statement?
Yeah, for example, if you replace something, I mean, the dependency, for example, in your example C, where the other one was replaced, I mean, there was a reason why it requires some other version. And so if you have many dependencies, maybe it could be dangerous to use the replace statement.
Oh, yeah, basically you're right. But from what I see from the Gomod files of Cryo and Kubernetes, they use replace statement for almost all of their direct dependency, and in this way they pin the exact versions.
Okay.
Yeah, you're right, basically. Yeah, let's we already have version D, and yeah, we run it. Let's run again. Oh, yeah, we have to go mode vendor D, run mode vendor make cake, and yeah, this is our output with D. So the last thing probably I want to show is how the breaking change and major versions are handled. So there is a concept called semantic import versioning, which means that if you introduce a breaking change, you have to update your module path. Let's see with the example here, the developer, the maintainer of package C. Is it visible here? Okay. It introduced breaking change. It changed he or she changed the signature of cake or death funk, which is a breaking change, and according to semantic import versioning, it has to change the module path in order to do not break other people. So the example that we use now will refer to package D. Currently, if we cut our Go mode, we are using v1 of D. There is another tag of D, which is v1.1, and which is referring the v2 of C. So basically, now we'll update our D to v1.1, and we're gonna see that in our project, two separate versions of C can exist in the same time. Basically, there's no magic. What are basically the Go modules force you, or yeah, they force you to change your module path when you execute, when you introduce a breaking change, and in this way, you all of your consumers have to update their import paths as shown in this example. Basically, this diff is coming from package D, and when they updated to v2 of C, they have to update also their import paths. And so in this way, for Go modules, it is like it is having two completely different import paths. So let's just go get v1.1 of D. And you're gonna see that it's detected that it requires v2, and it's already fetched and extracted it for us. Let's run go mod vendor. Let's see also the module graph. Here, our package A requires C, v1.1 of C, and the interesting that is d1.1 requires version 2 of C. Also with Go, I think it was Go list them all. You can see, you can list all of your direct and direct and indirect dependencies. So here you're gonna see that our project now requires the two packages with two different versions. Yeah, but note that the import path are different. Basically, the rule state that if you are introducing a major change, a major version increment, which according to Semver, it is a breaking change, you have to update also the module path, which basically is appending v and your major version to the module path. Okay, so if we now run our make cake again, yeah, but let's change our Go mode to refer not this C but v1c to get the same outputs, and let's vendor it, Go mode, and go run, and yeah, we have v1 output of C, and in the same time package D it successfully is able to consume v2 of C. Yeah, there's no magic as legit state in the guide. It's not magic. Yeah, it is behaving like two unrelated import paths. Yeah, do you have any questions? Basically, it was that was also yeah. Oh, okay, sorry. Also, there is one more. There are several things that I want to show. The first one is tidy. Basically, if we try to read the help of tidy, it will say that it will add any missing modules, or it will remove any modules that are not not relevant. So before any commit or any push, it's recommended to use the tidy command. So basically, your vendor your vendor in the makefile will be go mod vendor and go mod ID for updating the vendor. Also, yeah, you probably already saw that variable go 1.11 module. This basically force the Go modules. But currently, there are two modes. The one mode is the old mode, which is the Go path. And with Go module on, you can force your project inside Go path to use Go modules. As I said, this will be changed. The default mode in Go path from 1.13 will be the module mode. But yeah, when you opt your project into Go modules, it's recommended to use Go 1.11 module on everywhere, basically, to do not break guys that still use the Go path. Okay, some more utilities. The one is gomod y, and you pass with -m your module. Basically, it will show you why this module is required. Basically, in this output, we see that it is a module C is a direct dependency of module A. We're gonna see for version 2 of C, it will state that module A requires module D, and module D requires V2 of C. It is useful for debugging. Yeah, we already saw go list ML. It will list all of your dependency. You can also pass -JSON to see them where they are located in the module cache. What is the exact version? Yeah, we already checked gomod ID, and yeah, basically there are some utilities about how to edit the gomod file. For example, you can add replace statements, or you can drop replace statements with commands. But basically, I would suggest to directly open the gomod file in your editor and to add your statements here. Yeah, but it's okay to have also the commands. Also with the help, I recently discovered the help command. Basically, if you try go help and the command, it will show you the help information, which is quite useful. Yeah, go proxy, the go proxy environment variable, basically it is used to disallow Go to access the network. Yeah, to prevent Go operations from hitting the network. It is used. Yeah. Do you have any questions? I think it is all from my side. I want to share some links with you. Probably I'll put them in also in the video in YouTube. So this is the Go modules by example walkthrough. Here you have a lot of guides, and there are a lot of things that I didn't mention. For example, how to manage your two dependencies. For example, how you manage the version of Ginkgo and Gomega. There are some tools that are not in your build, but you use them for testing, for example. And you can use tools as dependencies. And yeah, I would suggest also to pass through this guide and the Go modules wiki. It is quite descriptive with a lot of information about the concept semantic import versioning, the minimal version selection, and nice sessions with frequently asked questions. Yeah, and also this link about the recording from Ligit's presentation to CKPI machinery. Do you have any questions?
Now, can you hear us?
Yes, I can hear you.
Okay. Sorry, we missed the last part. So are you at the end?
Oh, I think yes. Do you have any questions?
Are there any questions?
I don't have questions, but I like so much the references that you gave. So thanks for that. I think it's a very nice presentation.
Thanks.
Okay, thank you. Then the question, do we have any other topics for the community meeting? Okay, if not, then we close the meeting for today and see you next week. Bye.